So today we're going to talk about different ways that you can look at data. So we're going to be looking at different visual displays of data distributions today. So the first kind, which is not all that common, but the first kind of distribution is a uniform distribution. And this is where all of your bars are approximately the same height, meaning that your frequency or the number of times you have a certain result is about the same for every bar. So if you were looking at a class of grades, for example, and grades on a test, and maybe the scores are out of 9, and so a 0 through 9. And if it was a uniform distribution, that would mean that about the same amount of kids got a 0 as got a 1, as got a 2, all the way up through 9. So it's evenly distributed across the possibilities. A normal distribution is a lot more common, and you have probably seen these in a variety of different situations. One of the most common ones referred to is when you talk about your ACT or your SAT scores. And both of those are approximately normally distributed, meaning that most of the data occurs right around the mean, the middle, and then as you go away from the mean on both sides, it is evenly going down. So it forms this bell-shaped curve. So this picture here would be approximately normally distributed. A skewed distribution is kind of like if you took a normal distribution and you pulled the tail. So this picture here on the left that says U.S. household income, this would be a skewed to the right distribution. The skewed direction is always which way you would pull the tail, which way the tail is off to. So this is skewed to the right because the tail is pulled off to the right. So then the graph on the right that says year of birth, that one is skewed to the left, meaning that your tail is on the left-hand side. Another kind of distribution would be a bimodal distribution, and knowing that mode means the most frequent, a bimodal means 2 modes. So really you've got this situation where you have 2 kind of peaks to your graph, 2 different modes. And if you look at this one, the modes are right at about 12 p.m. and 7 p.m. So this would be a bimodal distribution. One other thing that you'll want to talk about with distributions is any outliers. An outlier visually looks like a piece of data that's kind of off by itself. So looking at this picture, your outlier for spent per month would be, looks like about $425. So that would be an outlier piece of data. You'll also have some gaps. You'll have a gap, which we'll talk about next, and that gap sometimes will indicate that you've got an outlier there. Outliers can seriously impact some of your averaging numbers that you would calculate, and we'll talk about that when we get to measures of center and measures of spread. But an outlier visually is a piece of data that is kind of out by itself. And if you were looking at a list of data, an outlier would be one that just seems weird, seems wrong. So if you're collecting data and you get a number that doesn't match up with the rest of your results, that would be an outlier. So then looking at this same graph, talking about gaps, you have a gap from about $300 to $400 where there's no data, and then all of a sudden there's another piece of data. So a gap is where you've got ranges in your graph where there isn't any data occurring, a kind of blank spot in your graph. So one other way that you can see a gap is sometimes you'll have clusters of data. So you might have a gap in between 2 or 3 or 4, however many clusters. So in this picture here, you've got a gap from about 1400 to just before 1500. And you've got 2 clusters of data. You have one cluster that goes from a little bit below 12 o'clock to about 1400. And then you have another cluster that goes from 1500 to probably about 1800. So you've got these two clusters of data where you've got data grouped together, and then you've got a gap in between the clusters. So you have different kinds of graphs. One kind of graph is a bar chart, and this is where I want to caution you in how you refer to your graphs. There are bar charts and there are histograms. Bar charts are looking at categorical variables. So you'll have bars in both of them, but in a bar chart, your bar is going to be a category. So in this one, you have an M&M's bar chart where your categories are the colors of the M&Ms: red, blue, green, yellow, brown, and orange. And then you have a count of how many in that category. The difference between a bar chart and a histogram, like I said, is the categorical, but what it also means is that you don't have, in a bar chart, the bars don't lead to each other. So you don't go from being a red M&M all the way up to, oh, now you're a blue M&M. You are one or you are the other. And a histogram is different. A histogram, when your bars are next to each other, they kind of lead to each other. And so we'll look at a histogram now. So in a histogram, most of the time your bars are a range of data. So you have a bar here on the left from ages 20 to 30. And the next bar is 30 to 40. So if you think about a piece of data in this data set, you have 20, 21, 22, 23, 24, 25, 26, 28, 29. And the second before you turn 30, you're still in that first bar. And as soon as you turn 30, then you're in that second bar. But because time, that age is a continuous piece of information. You have a second before you turn 30, you have a millisecond before you turn 30, and you'd still be in that bar. Because this is continuous data, that's part of what makes it a histogram. The other piece that's key to a histogram is you have some sort of piece of information you're collecting data on, for example, in this one, age. And then you have frequency is always the label on the y-axis. And frequency is how many times a piece of data fits in that bar, how many pieces of data you have in that bar. So, for example, in this one, there are 2 people between the ages of 20 and 30 in this data set. There are 4 people between the ages of 30 and 40. There are 4 between the ages 40 and 50, and so on. Frequency can be a count, an actual solid count, or frequency could be a percentage count as well. So you could see frequency as an actual number, a whole number, or you might see frequency as a decimal representing the percentage. The one other plot I want to touch briefly on today is stem plots. And stem plots you've probably seen in the past, but I just want to remind you of kind of the way we design a stem plot. The first thing is you need a key. And a key shows you what it means. It shows you how to read the stem plot diagram. So if you have a 2-digit number, which is typically what stem plots are used for, is 2-digit numbers. It gets a little bit trickier when you're trying to go anything beyond the tens. And so you basically will cut off the ones, and the ones digit will be the leaves, and the tens digit will be the stem. So in this example here, if you look at this one right here, that one represents something in the tens. So, for example, 1, 0, this would be 10. 1, 2, this represents a piece of data, 12. 13, 14, and there are 3 17s in this piece, in this set of data. So you have 1, 7 means means 17. So this 9 right here, because it's in this, it's off of this stem of 3, actually is 39. If you have ones, like up here at the top, then you have a 0 in your tens spot. So this would be 6, 7, and 8. So that's 3 pieces of data there. So that's just an introduction to visual displays of distributions. And welcome.